Okay. So today I'm going to demonstrate our Slang playground web app. Before that, I want to introduce what is Slang is. So Slang is a modern shading language, which is a cross-platform. Um, it means that you just need to run your shader once, and it support all the possible platforms currently. And for people who are familiar with C++, Rust, C#, Swift, Slang has all those modern features integrated. So I will show those features in my demonstration of the Slang playground. So here is the playground. So if you want to try Slang without installing anything, you can just open your Chrome or Edge or any web browser that support WebGPU. So the main panel here is the code editor. So we have already had the Slang language server support. So you will have the syntax highlight and the code completion. So like if you if I type something, right, so you can see that it can complete your code. Okay, so on the right panel, right up, this is the visualized window. So if your shader is runnable, so we can show the rendering result. But if your shader is not is not a drawing something, you can also print something. So like this, you can write a printf in your shader code. And this window can also output your shader's output. And on the red bottom, so first the panel is the target code. So since this is running on the web GPU, so the default target is the WGSL. So I will so this shader on the left, the Slang shader will compile to the WGSL. But we since I mentioned before, Slang is cross-platform, so we support all the different targets. So let's say if I want to compile a shader to Sphere V, just click it, you can see the Sphere V code. And it support HLSL, right? And the cool thing is that there is a line derivative embedded in the generated code. So you can easily find the corresponding source in Slang. So there is one thing to notice that is for the target like HLSL or GLSL, so you can only compile one entry point once. So you have to specify the entry point. But if you change the target like to WGSL or to metal, so you don't have to specify that. The other tab here is the reflection. Yes, Slang also support reflection. So by using the Slang reflection, you will know every type and for your shader data structure and the functions information and the binding point, etc. Everything you will know through the reflection API. Let's go to the demo again. Okay, so and if you write something wrong, right, and tap compile, so there is another tab show the compare error here. Okay, and this button is a share link. So if you want to share your shader, so if you're like this one, so if I make some change, okay, I change the color to very red, and I want to share the code to my friends. So I just click this button. So the shader code is embedded into the URL. So since the whole website since the whole website is built on the WebAssembly, so the compilation actually all the compilation and render run happens just locally. So after the first load, after the first load, you will not have any connection to the server. So that's why we use we embedded the shader code into the URL. So next, I want to talk about this preloaded demos. So first of all, we have three sections here. So for the first section, it shows how to use the utility functions defined in the Slang playground. So since Slang support the Slang module. So if you're familiar with Rust module or Python module or C++ share library, so it's a similar concept. It means that you can pre-compile your module and import your module here. So the whole shader, this final shader won't recompile the playground module, right? So it just need to link this module. So first, a few examples shows how to use some functionality like the printf, right? So this is implemented in the playground, and how to red color to the output canvas, and how to read image. So the last section shows the modern features I mentioned at the beginning. So like so anyone who familiar with C#, they know the property, right? So in Slang you can write a property, and we have a generic and extension. So it means that you can write a generic in your shader code. Actually, that is how I implemented the printf, right? Because printf has to accept all kinds of different types, right? So, and also extension. So you can also, let me see. Okay, so like this example, so we have the built-in float. You can even extend the float to conform to another type. So this is the extension. Next cool feature is the operator overload. So this is the common feature that anyone who read C++ must know, right? Slang also support that. And this is a very cool feature. We recently added this feature. So this is the variadic generics. So also this is the key feature that we implement printf. So consider that in the printf, the input parameter could be changed, right? So you cannot. So some legacy implementation will write like 15 function signatures, like take one parameter along to 15 parameter. But with variadic generics, you don't need to do that. The only thing you need to do is write a variadic generics here. So it can take infinite many parameters as long as you have enough GPU buffer to hold it. So it's a very convenient feature. The other the in the middle section, so that is where neural graphics come in. So I want to show our own implementation of the Gaussian splitting for 2D case. So let's take this simple example. So this is the initial status of the Gaussian splitting, right? We just initialize bunch of random splites here with random color, random alpha value, and the sigmas. And then we start training by running this example. So we start training and iterate, and we visualize the iterations here. So A will finally converge to the GIF image. But the cool thing I want to show is another new feature in Slang, which is the automatic differentiation. So by writing the neural graphics you have to write the derivative of your function. So traditionally, people have to write this manually. Like if you want to do it in CUDA or any C++, you have to write it manually. But Slang provides a called automatic differentiation. So if, if you define a function, you just need to decorate your function with a differentiable, differentiable declaration. So the Slang compiler will help you to generate the derivative automatically. So you don't need to write this manually, because writing the derivative usually is time consuming and also error prone, right? So a lot of people get crazy to write this thing. Yeah, for this example, right? So if you want to implement the Gaussian splitting, right? So you have to write the differentiable renderer, right? But to implement the derivative of a differentiable renderer is very time consuming. So this sample code with some existing like GLSL code or HLSL code to compare that how elegant and easily to implement this in Slang. Yeah, so that's all for the demo. Any questions?
Very cool stuff. Are you seeing a lot of uptake playing in the games industry, by game developers?
Yeah. So we have some early adopters, but so currently not all of people know Slang, right? So Slang currently is governed under Khronos. So actually, when you install Vulkan SDK, you have already installed Slang, so you can just use that. But Slang has it's not a very long history for Slang to go to public. So these are the early adopters. Like we partner with NVIDIA Omniverse team, and Adobe has some cool product already using Slang, and Portal with ray tracing also uses Slang, and yeah, Autodesk and also Valve also start using Slang. So we really hope that more people getting to know Slang and try it. Yeah, so yeah, hopefully it will, yeah, everyone will know it. Yeah. Sorry, I didn't hear some of the words. Oh, okay.
So with like 64-bit, for instance,
Yeah.
how do you kind of compile that into the route if it's being used in like a single paper, for instance?
Okay, I see the question. So Slang has a core. We have a core module. So we implement all the intrinsics there. So if something is supported on WGSL as intrinsic, like you said, 64-bit atomics, right? So that is intrinsic in WGSL. So we will have the same implementation in Slang as an intrinsic. So we have a lot of intrinsic implemented in Slang to support different platforms. Like HLSL, GLSL Metal, they all have their own intrinsics. So we have to implement all of them to support different platforms. Yeah, so that's how we support VXO.
Okay.
Yeah.